All right, guys, we're in chapter 8, section 7. So previously we factored trinomials of the form x squared plus bx plus c. Now we're going to factor trinomials of the form ax squared plus bx plus c. So if you remember last time, we factored polynomials that just had x squared out front. And now we're going to consider situations where the leading coefficient is not 1. Like it might be 5, 7, 9, negative 14. Different things like that. And then we're also going to solve equations of the form ax squared plus bx plus c equals 0. And we're also going to talk about something that's called a prime polynomial. You've heard of prime numbers. Well, now we're going to talk about what happens if you have a prime polynomial. And remember, a prime number is a number that has no other factors except 1 in itself. So we'll look at what that means. So in the last lesson, you factored quadratic expressions of the form ax squared plus bx plus c, where a was always 1. In this lesson, you're going to apply factoring methods to quadratic expressions in which a is not 1. So the dimensions of the rectangle formed by the algebra tiles are the factors of 2x squared plus 5x plus 3. Notice that the value of a in this problem is 2, not just 1. The factors of 2x squared plus 5x plus 3 are x plus 1, and you could see it, x plus 1 right here, and 2x plus 3 right here. Now, if you multiply x plus 1 and 2x plus 3, you get x squared, 3 x's and 2 x's, which make the 5x, and 3 1's, which make the 3. So you can also use the method of factor by grouping to solve that expression. So apply the pattern 2x squared plus mx plus px plus 3. Well, notice you have to find two numbers that have a product of 6 and a sum of 5. Okay, where do we get that from? Well, basically when we factor a trinomial where the leading coefficient is not 1, you multiply the first and last terms as long as it's in standard form, which gives you 6. And you have to find factors of 6 that make the middle term. Well, 5, okay? So we list out all the factors of 6. Now, in this case, they multiply to a positive 3 and add to a positive 5, so both factors have to be positive. So the only factors of 6 are either 1 and 6, or the other pair 2 and 3. Which of those add to 5? Well, 2 and 3 add to 5. So what you're going to do is break up the 5x as two factors or two terms of 2x and 3x. So you break apart the 5x to two terms rather, of 2x and 3x. And remember, we got those from the factors of 6 that added up to that middle term. Then you use factor by grouping. Group the first two and the last two. Factor out the GCF of each one. And what's left should be the same factor in the parentheses. So here I can factor out a 2 and an x. And here I can factor out a 3, just a 3. Now be careful, when the GCF is all there is, like in this case, the GCF of 3 is 3, when you factor out a 3, that term, you're left with a 1. It doesn't just go away, okay? And then the GCF of both of these is x plus 1, so you're left with 2x plus 3 times x plus 1, okay? So therefore, the trinomial 2x squared plus 5x plus 3 factors into 2x plus 3 times x plus 1. So there's the key concept. Whenever you factor trinomials of the form ax squared plus bx plus c, you find factors of the product of the leading coefficient in the constant term, so a times c. You find factors of those that add up to the middle term. So in this example, you have 5x squared plus 6. You multiply 5 and 6, and you would get 30. Okay? Now, you want factors of 30 that add to negative 13. Well, since the two factors have to multiply up to a positive and add to a negative, they both have to be negative. So you could do negative 1 and negative 30, which would be negative 31. That's not going to work. Negative 2 and negative 15, which add to negative 17. That's not going to work. Then you do negative 3 and negative 10, which gives you negative 13. And that's what we're looking for. So you use the negative 10 and the negative 3 to break up negative 13, so negative 10. negative 3. And here you factored out a 5 and an x from both of these two. Group those two. You can factor out a 5x. And here, you're going to have to factor out actually a negative 3. So if you factor out a negative 3, it leaves an x minus 2 because you want both of these factors to be x minus 2. You factor that out and you get 5x minus 3 times x minus 2. Okie doke. All right, so here's one for us to try. So if I factor 7x squared plus 29x plus 4, so you multiply the a and c. So a is 7, c is 4, so that makes 28. You list the factors of 28 and look for the pair whose sum is 29. Since 4 is positive and the numbers they have to add to is positive, both factors have to be positive. Now, 1 and 28, I got lucky because that one added to 29. I could have had 2 and 14, but that adds to 16. I could have had 4 and 7, but that adds to 11. And those are all the factors of 28. Okay? So then I take my 1 and 28 and break the 29 up into 1 and 28. So it's 7x squared plus 1x plus 28x plus 4. Okay? Now the question always comes up, how do I know which one to make the 1 and which one to make the 28? Well, it doesn't really matter, because watch this. If I do the 7x squared plus 28x plus 1x plus 4, these two I can factor out a 7 and an x, which would be the x plus 4. And then these two, nothing, there's no GCF except 1, so just do factor out the 1. Okay, and notice both of them have an x plus 4 left over. And if you factor out the x plus 4, you're left with 7x plus 1. Okay, so really, as long as you get the two factors correct that multiply, that add, it doesn't matter which way you put which one. Okay, so if you look at part B, notice if you put all three terms together, if you look at all three terms, you can factor a 3 out of all of those. So if I factor a 3 out of all of those, I get 3 times x squared plus 5x plus 6. Now this x squared plus 5x plus 6 is one of those old ones where all I need to do is just find factors of 6 that add to 5, because the leading coefficient of the x squared is now just 1. So that simplifies to finding factors of 6 that add to 5, they're 2 and 3. So it'd be 3 times x plus 3 times x plus 2. Okay, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So the first thing you should always look for is a GCF of the three terms. Now, if you look at number 1, there is no GCF, but number 2, you could factor out a 2, or part B right here. So let's do part A first. I multiply the 5 and the 6, I get 30, and I need factors of 30 that add to 13. Notice the 6 is positive and the 13 is positive. So both factors have to be positive. So factors of 30, 1 and 30, but that adds to 31, so that's not going to work. 2 and 15, but that adds to 17, so that's not going to work. 3 and 10, that adds to 13, so that works. So you have 5x squared plus 3x plus 10x plus 6. Now you could have done plus 10x plus 3x. It would have worked either way. So from the first two, you group those two, and the only thing you could factor out is an x. So you're left with 5x plus 3. Group these two together, the only thing you can factor out is a 2, and you have 5x plus 3 there as well. So then you have x plus 2 times 5x plus 3. Okay? This next one, if you multiply the negative 8 and the 6, you get negative 48. But notice you could factor out a 2 as the GCF. So you'd be 2 times 3x squared plus 11x minus 4. Now you multiply the negative 4 and 3 and you get negative 12. Well, I need factors of negative 12 that add to 11. Okay, since the factors add to or multiply to a negative 12, one has to be positive and one has to be negative. And since their sum is positive, that means the bigger number has to be positive. So I could try 12 and negative 1. You add those together, and you do get 11. We got lucky. You would not have to consider -1 or -12 and 1, because those are going to add to a negative number. Okay, only factors where the bigger number is positive. You could do 6 and -2 and 4 and -3, but in both cases you get 4 and 1, and they're not going to work. Okay, so I got 12 and -1. So you do 3x squared plus 12x minus 1x minus 4. Group the first two together. You can factor out a 3 and an x, so you'd have x plus 4. Notice these two, there's not really a GCF, but you want it to be x plus 4, so you can factor out a -1. So this would be 2 times 3x minus 1 times x plus 4. Okay, don't forget to write the 2. When students factor out the GCF, if there is one, lots of times they forget to put it in their answer. Okie doke? All right, sometimes the coefficient of the x term is negative. So the middle term here, the b is -17. What do we do? Well, you start off and you multiply a and c together, so you get 60. And I need two factors of 60 that add to -17. Well, since the product's positive and the sum is negative, the only way you get a positive number from negatives is if you multiply two negatives. So I need factors of 60 that add to -17. Well, if you list them out, both factors have to be negative, so -5 and -12 works, because those add to -17. So then I rewrite the -17 as x as -12x and minus 5x. So you have 3x squared minus 12x minus 5x plus 20. And then factor by grouping. Group the first two together and the last two. Take the GCF out of the first pair, which is a 3x, and the GCF out of the second pair, which would be 5, but you also take the negative so that the factor that remains is x minus 4. Okay, then you finish it off with 3x minus 5 and x minus 4. All right, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So the first one, multiply the 2 and the -1, you get -2. And I need factors of -2 that add to -1. So -2 and 1. Remember, since the middle term is negative, the bigger factor has to be the -1. So that adds to -1. So you have 2n squared minus 2n plus 1n minus 1. I'm going to break apart the -1n as -2n plus 1n. I do that so that I could group together and factor out the GCF of 2n from the first two. You get n minus 1. And then the second pair has no GCF, so it's just a 1. And then you finish it off with 2n plus 1 times n minus 1. Okay, and that's our factored form. Second one, did you notice that you could factor out a GCF of 5? So if I take a 5 out of everything, that simplifies to 2y squared minus 7y plus 6. Okay, then I multiply the 2 and 6 and get 12, and I need factors of 12 that add to -7. So -1 and -2, -12, that'd be -13. -2 and -6, that adds to -8. -3 and -4, that adds to -7. That's the one I want. So I have 2y squared minus 3y minus 4y plus 6. Group these two, so you have 5 times. You factor out a y from the first pair, so you have 2y minus 3. And the second pair, you'd have to factor out a -2, so that what you're left with is 2y minus 3. So that becomes 5 times y minus 2 times 2y minus 3. Okie dokie? All right. A polynomial that cannot be written as a product of two polynomials with integer coefficients, I should say, is called a prime polynomial. So look at this one. Factor 4x squared minus 3x plus 5 if possible. If the polynomial cannot be factored, you just write prime. So since A is 4 and C is 5, the product of the A and C term is 20. Now I need to find factors of 20 that add to negative 3. So negative 20 and 1, negative 21. Negative 4 and 5, negative 9. Negative 2 and 10, negative 12. And that's all the factors. None of these factors of 20, those are all the possible factor pairs of 20, none of them add to, what were we looking for? Negative 3. So therefore, the polynomial cannot be factored. So there's no factors with a sum of negative 3, so it can't be factored using integers. Therefore, the polynomial is prime, and you would just write prime as your answer. All right, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So the first one, you got 4 times 7 is 28. Now I need factors of 28 that add to 7, so or add to negative 1. So the larger number would have to be negative, so 28 and 1 gives you negative 27. Negative 14 and 2 gives you negative 12. Negative 7 and 4 gives you negative 3. And there are no other factors. If you keep going down, the next factor would be 4, but 4, it would be negative 4 and 7. And there your bigger number is positive. So these are the only 3 factor pairs you need to consider. None of them work, so it's prime. So this one, if I multiply 2 times negative 5, I get negative 10. And I need factors of negative 10 that add to a positive. So my bigger factor has to be positive. So 10 and negative 1 gives you 9. 5 and negative 2 gives you 3. Okay, so this one can be factored, it looks like. So you have 2x squared plus 5x minus 2x minus 5. Factor out an x from the first group. So group these, and you get 2x plus 5. Factor out a negative 1 from those, and you get 2x plus 5. And then you have x minus 1 times 2x plus 5. Okay, and so that one is not prime because you can factor it. All right, hope that was helpful to you. If you have any questions, let me know, and stay tuned for the next video.